In this video, we're going to continue working with quartiles. So recall that with quartiles, I divide my data into 4 pieces, and I have Q1, Q2, and Q3. Now, if I look at the data, this part represents 25%, 25% here, 25% here, and 25% here. And so whenever I'm looking at this, I want to determine this middle region. That middle region is called the interquartile range. The interquartile range identifies the middle 50% of the observations. So that is looking at this area right in here. Well, interquartile range, IQR, is Q3 minus Q1. This is the formula that we use in order to calculate that middle 50%. We're taking the Q3 minus the Q1, and so we're looking at that range there. Now, when we're looking at this, be sure your interquartile range should be a positive number because you're taking the highest number minus the lowest number. Recall that range is your highest value minus your lowest value. So let's look at example 5. Determine and interpret the interquartile range of the speed data in the previous example. Now, in the previous example, we had that Q1 was 28, Q2 was 32.5, and Q3 was 38. To find the interquartile range, I'm going to take my Q3 minus my Q1. So I get that my interquartile range is 10. What this represents is that there's 10 miles per hour that we're looking at to get that middle 50%. So the range of the middle 50% of the speed of cars traveling through the construction zone is 10 miles per hour. Now suppose that a 15th car travels through the construction zone at 100 miles per hour. How does this value impact the mean, the median, the standard deviation, and the interquartile range? What I've done here is I have actually calculated the mean without the 15th car, in other words, our original 14 data values. I highly recommend that you go back and actually do that calculation on your own. We had calculated the median, Q2. We calculated the standard deviation. We did not in this particular item, so I highly recommend you going back and seeing if you can get the same standard deviation. And we calculated the interquartile range. Well, now, using the 15th car that's going 100 miles per hour, notice that the mean increases to 36.7 miles per hour. The median doesn't really increase very much. It increases to 33. Notice the standard deviation. This is the spread. We're spreading them out more. So that is actually at 18.5 miles per hour. The interquartile range doesn't change much either. So if the dispersion is symmetric, meaning that it is the bell-shaped, the central tendency, mean, is the best measure of dispersion. Or, I'm sorry, the central tendency is best measured by mean, and the best measure of dispersion or spread is the standard deviation. This is because we're looking at sides being equally distributed. Now, if it is skewed left or skewed right, we tend to want to use the median as our measure of central tendency and the interquartile range as our measure of dispersion or spread. The reason why is because median and interquartile range are resistant. They resist those outliers, whereas the mean and the median, the mean and the standard deviation do not. Now, I've been bringing up the outliers quite a bit, so let's look at what an outlier actually is. An outlier is an extremely high or extremely low observation. It's those extremes. In order to check for outliers, we're looking at the data. We determine our first and third quartiles. The reason why we need those is because we need that interquartile range. Then we're going to determine the fences, and we call them fences or boundaries, either one. They serve as cutoff points for determining our outliers. So in other words, if anything's outside those fences, it's considered an outlier. So let's look at the lower fence of our data. That is going to be equal to our Q1 minus 1.5 times our IQR. This 1.5, it gives me that additional interquartile range plus a little bit extra. So when we're looking at these, we want to take that interquartile range plus 1.5 of those on both sides. Anything outside of those items is considered an outlier. So our lower fence took Q1 and went left with it. We subtracted. Our upper fence is going to take Q3 and we're going to add this value to it because we're going the other way. So let's look at, let's say this is Q2, this is Q3, this is Q1. So what I'm doing is I'm calculating this value, and then I'm going to take that value and extend it a little bit on this end, and I'm going to get a lower fence. And I'm going to extend it on this end, and I'm going to get an upper fence. Anything outside these fence lines, whether it be down or up here or down here, is considered an outlier. So let's look at our speed data for outliers. We have already calculated that Q1 was 28 and Q3 was 38. This is going back to our original 14 data points. So our IQR is going to be 38 minus 28, which was 10. Let's look at the lower fence. The lower fence is going to be 28, my Q1, minus 1.5 times my IQR. 1.5 times 10 gives me 15. So I'm going to take 28 minus 15, which is 13. My upper fence is going to be on the other side of my data, so it's going to take my Q3 and I'm going to add 1.5 times 10. So I have 38 plus 15. 38 plus 15 gives me 53. Now make sure that when you're doing this that you do this multiplication before you do the addition subtraction. Just a reminder. So when I look at this and write down my data values that I have for those speed limits or the speeds of the people, we had 20, 24, all the way up to, we had 2 different 40s. Okay? Now if I include my fences, my lower fence is down here at 13. My upper fence is here at 53. I do not have any data values less than this fence or outside this fence on the left hand or outside this fence on the right hand. And what I tend to do is I tend to box in my data to see if there's anything outside of that data box. If there's anything outside that data box, that's considered an outlier. So this particular problem does not have any outliers. Let's continue looking at compute the 5-number summary. Remember that I told you the 5-number summary included the minimum value, the Q1, the Q2, the Q3, and the maximum observation. These are our 5-number summaries. So let's look at example 7. Every 6 months, the United States Federal Reserve Board conducts a survey of credit card plans in the U.S. The following data are the interest rates charged by 10 credit card issuers, randomly selected for the July 2005 survey. So this is older data. Determine the 5-number summary. Well, we're given the data right here. So in order to determine the 5-number summary, we have to get the minimum, the maximum, our Q1, and our Q2. So let's first put these in order from the smallest to the largest. And I'm going to let you pause the video and do so. Okay, so I have placed these rates in order from the smallest to the largest. I want to find my Q1, Q2, Q3. Again, you can do this either way, but what I'm going to do is for my Q1, I'm going to calculate the location. So that is 0.25 times how many data values I have. I have 10 different credit card companies. So that gives me 2.5, which I round up to the 3rd position. The 3rd position is 12%. My Q2, if I do the location, that's 0.5 times 10, which is going to give me 5. So that means I need to take the 5th and the 6th data value. 1, 2, 3, 4, 5, and 6. So that's going to be 13.3 plus 13.9 divided by 2. Q2 is going to be 13.6%. Q3, the location is 0.75 times 10, which is going to give me 7.5. So I'm looking for the 8th position. 1, 2, 3, 4, 5, 6, 7, 8th position. 14.4. This is 3 of my numbers. I'm going to kind of underline those or box them. Here's 1, here's 2, here's 3. I want the 5-number summary, so I include the minimum of 6.5% and I include the maximum of 14.5%. This is my 5-number summary. Go ahead and practice quartiles, interquartile range, 5-number summary, and in the next video we will discuss box plots.